Three is graphing techniques. So you follow certain things in order for you to, well, graph experimental data. So a well-designed graph will quickly and easily represent a huge amount of information. So we can actually define a graph. So a graph just represent, it represents visual representation. It represents visual representation of the relationship between variables. Okay, so visually you can see the relationship of two quantities by using the graph. That's why, again, you can analyze it much clearly, comparing it with you just have a table. Okay, so there are certain things that you need to remember when you try to graph your data. So first things first is you need to identify your variables. Okay, so it is a general rule that the independent variable is plotted along the x-axis. So remember that in a Cartesian coordinate plane, it is consist of x and a y, wherein the common point of intersection is the zero or the origin. So when you plot your variables, it must be that the x-axis would represent your independent variable. So whatever is your independent variable, it should be plotted here. So if you will be asked, how would I know in a particular experiment that my variable or that particular quantity is my independent variable? So actually, the independent variable is the variable that is changed in the experiment. Okay, so let's say, for example, if you're gonna study motion the motion of a particular object, so in your procedure, let's say, for example, you're gonna take or you're gonna measure the distance covered by the object every 1 minute. Okay, so every minute you take or you measure the distance. So in that particular case, given the procedure, the dependent variable is the time, because you're changing the time. And the dependent variable, on the other hand, should be plotted along the y-axis. So therefore, this should be the dependent variable is plotted in the y-axis. Okay, so one way of looking at the dependent variable is that it is the variable that is being measured. Okay, so for the time, as I mentioned in my example, if you want to study the motion of the object, so you're taking or you're measuring the distance of the object covered by the object every minute. So you set that one, you no need to take the time, because you try to, again, measure the distance every minute. So you set that one. So the independent variable is the time, and the dependent variable is your distance. So the one that is being measured in your experiment. Okay, so After you identify the independent and dependent variable, determine the range. You might be thinking about range as just the y values, but the range only means that what would be your minimum and maximum values. So the minimum values and the maximum value of each axis. And since graph is a visual representation of the relationship between the two variables that you are examining. So in my example, distance and time. So you need to make a graph that is big enough. So that is why it is advisable to use at least 3/4 of your graphing paper. So this could be anything of your screen. So there's no point of having a very small size of a graph. Okay, because the purpose of the graph will give you a visual representation or the visual thing. So if you cannot, if you have a very small one, well, that defeats the purpose of your graph. Okay, and next up, don't forget to label. Okay, and the numbers to both axes and the units. So let's say, for example, in my case, if I'm studying distance over time, so I'm gonna place distance and then the unit m. So let's say it is in meter. So take note that the unit is placed in brackets. My x, since based on my experiment, time is my independent variable, so I place time, and then let's say I mentioned about minute, so the unit should be in minute. So again, I'm gonna place it inside a bracket. Okay, and then let's say I have these data points here. If you can remember your plotting, it's also the same thing as plotting in your math. So let's say I have data points here. Okay. So let's say, for example, these data points, if you can see, it is not necessarily all the data points will fit in a single straight line. However, when you try to draw your curve, you have to remember that just draw whichever is fitting of the general trend of your data points. So in this case, if you can see, well, all of them are increasing, so that represent a straight line. But remember that that is not always the case. Okay, that is why you need to remember that no need to connect the dots. So do not connect the dots. Okay, so therefore, let's say if you have decided that it is a straight line that would best represent my data points, so draw a straight line. So you can use a ruler. And if you can see, doesn't also have to start at 0. So just draw a line that could represent all your data points. So for example, in my case, yeah, this would be the best one. So I can draw that one out. So if you can see, my straight line doesn't hit all the data points, and that is correct. Again, do not connect the dots. Again, just try to examine what would be the best curve that fits your data points. So if it's a straight line, draw a straight line. If it is a quadratic, draw a quadratic form. If it is radical, so you draw a radical function. And then lastly, you need to add a title. So the basic title is just the, well, in your case, you're plotting the distance versus time. You can just place distance versus time graph, distance versus time. Okay, so the y variable and then the followed by the x variable. So I can write it that way, distance versus time. So that's the title of my graph. Okay, so as I mentioned earlier, well, the most common one, at least that you are familiar with, that you are familiar with, is a graph that gives a linear relationship. So if you have a straight line, so this means that y varies directly with your x. Okay, so dependent variable changes linearly with the independent variable. So if you have a straight line, again, the dependent variable changes linearly with your independent variable. And if you can remember that the equation is given as y is equal to mx plus b, wherein m is the slope and this is the y-intercept. Y-intercept. So these are two examples of linear graph, wherein the first one here, this gives you a positive slope, and the other one gives you a negative slope. This line here is your negative slope. Well, the slope could represent certain quantities. Let's say, for example, if you're graphing distance versus time, slope gives you the average speed of your object. So if you're talking about the y-intercept, this is the value of b here. So that is your b. So this is the y-intercept of this graph, and this would be the y-intercept of the other graph. So y-intercept is just the point upon which your line hits the y-axis. So that's how we define. So quadratic relationships, okay? So when a ball is dropped, the distance versus time graph will not be linear. So this data represents a quadratic or parabolic function. So if you can see in the previous one, again, you can write it at y is proportional to x. So if you can see in this graph here, this is a quadratic graph. Maybe what you're quite familiar of is that the whole parabola thing. That usually the negative, we don't have a negative time. So it follows this one. Well, we'll be doing free falling. So we will study the motion later on when we talk about kinematics. But the graph of a falling object would look like this. Okay, so maybe the position here, this would be taken as just the distance, or you take the downward as your positive. You can also do that. But anyway, when you try to graph the motion of a falling object, it should give you this form here. And this particular graph here is a parabola or quadratic function. And the equation is given by So if you can see, this is another way. If your data points is something like this, don't make a straight line, because the one that fits all the data points is a parabola. So the equation of a parabola is given by ax squared plus bx plus c, where a, b, and c are just constants. So if you can see here, a quadratic equation, it only means that you have a square in your variable x. And this relation shows that y varies directly with the square of x. Okay? So see the difference. If you have a linear one, so a straight line, y is directly proportional to x, or y is proportional to x. But if you have this graph here, if the graph is something like this, you would expect that it's not a linear graph, but somehow curved, a parabola. And again, yeah, y is proportional to x in this case, the square of x. So it's no longer y directly proportional to x, but y is directly proportional to x squared. That means that if I'm gonna square the value of x here, and then I'm gonna plot it again, I should get a straight line. Okay? So that means that all of the value of x here, if I'm gonna take the square for the same position, if I'm gonna graph them again, I will get a straight line. So that's the meaning of this, that y is proportional to the square of x. Okay? And inverse relationship. So these are just some of the common relationship that you will encounter in your study of physics. So inverse relation tells you that as one quantity decreases, well, as the value of x, if you can see here, as the value of x increases, the value of y decreases. Okay, so some particular common quantities that follows this relationship is the current versus resistance. Okay, the gravitational force versus the distance. So that means that if you increase the distance, the gravitational force decreases. Okay, so as well as current versus resistance. That means that if you increase the resistance, current should decrease. So if you have that relation, we call that one inverse relationship. So they exhibit inverse relationships. Okay, and the equation is given by just y is equal to k over x. Oops. So y is equal to k over x. Or again, if you're gonna say the relationship, y is inversely proportional to 1 over x. Okay. So same thing as before. That means that if I gonna do the inverse of, or actually if you can see 1 over x is just the same thing as like taking the reciprocal of x. So if I gonna graph that one, the value of x, but trying to get the reciprocal, I should get a straight line. Okay. So again, this particular relation tells you that as x increases, y decreases. So if you increase the x value, the y value decreases. So if in that particular case, that would be inverse relationship. So any questions about the three? Well, these are just some of the common relationships that you will be encountering, especially for the first one and the second one, because when we talk about projectile motion and freely filling object, the motion of those follow a parabola. If you're gonna graph the position against time, it's a parabola. But for objects moving with a constant velocity, well, in that particular case, you're gonna be getting, if you're gonna graph the position against time, you'll get a straight line. Okay, so any questions with this one here? Well, if you're wondering, why is it that y is proportional to the x squared, right? Well, I mentioned that when you graph y and the square of x, I will get a straight line. Because remember the proportionality symbol here, this will give us a straight line. So maybe I can show you an example on that, like for what it means. Let me just change the graph here. So let's say a common, it's a basic one. Let's say y and then x. So let's say 0, 0. This is 1. This is 1. If this is 2, this would be, let's say 4. If I have 3, this is 9. And then let's say 4, you have 16. So if I gonna graph this one here, let's say this data. So see what would be the relationship of this data here. So 0, 0, again, this is my x, this is my y. So it could represent any quantity. So 0, 0 would be here. And for the scaling, for the value of x, I just have 4. So 1, 2, 3, 4. So this would be 1, 2, 3, 4. And then for my y, the maximum is 16. So it must be, I should fit all of them in here in the along the y axis. So 2, 4, 6, 8, 10, 2, 4, 6, 8. So maybe I can use 2, 4, 6, 8, 10, 12, 14, and then 16, then 18. Okay. So for 1, it's 1. For 1, it's 1. So it's somewhere here. And then for 2, it's 4. For 3, it's 9. And for 4, it's 16. Okay. So plotting the data points, if you can see, that is not a straight line. So therefore, this is a quadratic function. Okay. So a parabola, actually half of the parabola. So we say that for this function here, y is directly proportional to the square of x, right? So, well, to show that indeed your y is directly proportional to the square of x, I can plot this one again here, like this is just taking the square of x, right? So if I gonna square the x here, so that means that the value of x taking the square, so this is 0, this is 1, this is 4, this is 9, and this is 16. So again, the third column here, I'm just taking the square of x. So if you can observe what happens to my graph if I'm gonna do that. So again, I'm not changing my value of y. It's the same thing. So I'll be plotting these two here, this and all of this. So same value of y, but I'm changing the value of x. So again, this is now x squared, this is y. So see what happens. This is maybe I can no longer use 1, so maybe 2, 4, 6, 8, 10, 12, 14, and then 16. Then same thing here, the minimum is 0, so 2, 4, 6, 8, 10, 12, 14, 16, 18. So now if I'm gonna plot that one again, see what happens. 0, 0. And then for 1, it's 1. For 4, it's 4. It's 4. And then for 9, it's 9. 9 is somewhere here. And then for 16, it's 16. So if you can see, generally there, that is just a straight line. Although not perfectly, because I approximated the half portion. But if you can see, this becomes a straight line. So is it not that if I'm gonna represent their relationship, this is y is directly proportional to the square of x. Okay, so actually what I did here is just showing that indeed y is directly proportional. So that means that as I increase the square of x, y also increases. That is why it becomes linear. Okay, so the meaning of this one is same thing for the inverse function. That means that at first, if I'm gonna graph y versus x, I'll get this graph here. But if I'm gonna graph the reciprocal of x against the y, again, the same value of y, I'm just changing the value of x into 1 over x, I should get a straight line.